Look at this figure. You know that this is a circle. Its center is the point P. Line segment PA is a radius of this circle. The line segment MN that passes through the center of the circle and touches the circle at two distinct points is called a diameter of the circle. Now, look at the line segment YZ. It touches the circle at two distinct points. This is called a chord of the circle. The diameter of a circle is nothing but a chord that passes through the center of the circle. Now, let's consider these points that lie in the plane of the circle. Here we can say that points N, Y, V, Z, N and A lie on the circle. Points P, T and U lie in the interior of the circle. And points W, L and O lie in the exterior of the circle. The circle and its interior together make up what is known as the circular region. Okay, let's now focus on the chord YZ. You will see that this chord divides the circle into two parts. Each of these parts is called a segment of the circle. The smaller of the two, that is YVZ, is called the minor segment, and the bigger part, that is YMZ, is called the major segment of the circle. Now, consider point W as shown. If we complete angles YVZ and YWZ and measure them using a protractor, we will find that their measures are equal. Similarly, if we consider point O and complete angles YMZ and YOZ, we will find that their measures are equal too. This shows that angles in the same segment of a circle are congruent. Now, let's consider the diameter MN of the circle. As we have already understood, the diameter is also a chord of the circle, which divides the circle into two segments as seen. Since the diameter passes through the center of the circle, the segments it forms are equal in size and are called semicircular regions. Here, segments MVN and MXN are both semicircular regions of this circle. Now, consider point K and complete angles MVN and MKN as shown. When these two angles are measured using a protractor, we will find that they both measure 90 degrees. This is found to be true for any angle plotted in a semicircular region of a circle. This means that an angle in a semicircular region of a circle is a right angle. Let's understand how the measure of an angle inside a segment of a circle is related to the size of the segment. We just saw that the angle in a semicircular segment or a semicircular region of a circle is a right angle. As the size of the segment decreases, we see that the measure of the angle increases. Hence, we can say that the angle in the minor segment of a circle is an obtuse angle. Similarly, as the size of the segment increases, we see that the measure of the angle decreases. That is, the angle in the major segment of a circle is an acute angle,